everybody. Welcome to a special edition of Reverse the Verse Live here in the Taggart conference room. The beautiful, stylish, Keith is shaking his head over there, Taggart conference room in Wilmslow, United Kingdom. I'm your host, content manager for global video production, Jared Huckabee, and today we are joined by an esteemed panel of engineers and QA and programmers here to discuss a topic very close to my heart. I was going to say something funny like basket weaving, but no, it's object container streaming. Now, object container streaming is something we've been talking about for a long time. When we started the conversation about serialized variables, once upon a time, from bind culling, object container streaming, network performance improvements, all these different topics that all kind of roll into an overall performance improvement for Star Citizen. We want, as we approach 3.3 and the inclusion of Hurston and object container stream stuff, we wanted to take one of these last opportunities to really dive into what this system is and explore the work that's being done and maybe dispel a couple myths about it, because we see a lot of misinformation on the forums and stuff like that. People thinking it's a silver bullet that's going to solve every problem in the world and stuff like that. So I really want to take some time to talk through exactly what object container streaming is and what it means for Star Citizen. Before we do that, we do the same thing every week. We assume that nobody has seen any other episode of Reverse the Verse before, so let's take a few moments and introduce ourselves. And we'll start over here with you, Gordon. Who are you and what do you do for Star Citizen?
I am Gordon McLean. I'm a senior gameplay programmer on the FPS team here in Wilmslow. So my main remit is the actor. So I own the actual player and any sort of humanoid type person running around.
Gotcha.
So I've been here for like 3.5 years now.
I was going to say, you've been here just about as long as I have.
Yeah, I've been here for quite a bit now. So yeah.
Yeah. And you said most of your focus is on FPS stuff, but what have you been doing with regards to object container streaming?
Yeah, so I was sort of drafted in as support, gameplay engineering support for object container streaming. So it's a lot of sort of mostly bug fixing and sort of fixing peripheral issues around OCS. Probably the main biggest one was the likes of the mission markers, for instance, so making them work with OCS, tracking a mission when you're out of range of it and such like. And then general performance stuff as well.
Tracking all the stuff that he brings up.
Yeah, pretty much. Yeah.
So, Chris, who are you and what do you do for Star Citizen?
I'm Chris Eckersley. I'm lead technical QA in the UK.
And what do you do for Star? So, what does that do?
So we're part of the main QA department, but we tend to handle more of the tools and techie side of things. So we tend to be a bit more hands-on with the servers than the rest of the department, which is why OCS and bind culling stuff tends to fall our way.
Gotcha. So less of the gameplay stuff. A big misconception about QA is that it's just playing the game all day. You're sitting there beating on the tools and the servers and the back end and stuff.
That's right. Yeah.
Gotcha. And last but certainly not least, Clive, who are you and what do you do for Star Citizen?
I'm Clive Johnson. I'm the lead network programmer. What do I do?
You're Mr. Happy Fun Time.
Yeah, program a little bit of networking. Try and avoid going into meetings. My main focus is the client server networking rather than the back end side. So it's getting the game client to talk to the server and get the information back as efficiently and with as little bandwidth as possible.
Gotcha. Now, we've featured Clive on other shows about networking, about bind culling and stuff like that. We are, as always with Reverse the Verse, we are going to be taking questions live from the Twitch chat, where you can submit your questions with the word question in capital letters surrounded by brackets. You can also do so in Spectrum, our live communication platform on robertspaceindustries.com. The question period is going to come a little bit later, because I want to start with an oral journey, if you would. I want to shake things up a little different. I only get 1 week a year in these other studios. So now I've got you all here all in a room. You can't fake, the Skype call went down or whatever, because I'm here. Let's just talk about OCS in general. Let's start at the beginning. What were we trying to achieve with OCS? What was... we started working on OCS, I think, when I was talking to Luke Hale, who was the associate producer that handles a lot of your work. He said the earliest works on this started about 3 years ago. Yeah. When we started work on OCS 3 years ago, what were we trying to achieve?
The the main concern has always been trying to fit Star Citizen onto a player's computer. Obviously, servers tend to be a lot more powerful than the domestic user's computer, so having all this expansive solar system, all the planets, all the locations, all the ships loaded in all the time is just not possible, not without masses and masses of memory, which is much more than your typical user is going to have. So the primary concern is just making the game fit, breaking it up into smaller chunks that can fit on each player's PC.
Gotcha. When we started moving towards 360-degree, fully realized moons and planets, and wanting to do that without loading screens, you leave up from one, and you don't want to, like, you set course from Hurston to Microtech, you don't want to go, quantum jump, and then it goes loading screen, and then and change that. Object container streaming was the tech that we wanted to be able to seamlessly move. Like when you turn away from Hurston, you move away from Hurston to pull Hurston out of a client's memory, and then feed in Microtech, and then vice versa. And it's not just the juggling of the client side; it's also the server side. I understand it's doing the same thing with the server, because even once we start putting in all these space stations and planets and moons and everything, servers still have a finite amount of memory, finite amount of processing power. So there's client side OCS, and then there's still a server side component. So am I right with that?
That's right. That's not something we're working on for 3.3. That will be further down the line. But yeah, because the solar system is going to get even more densely populated and more planets and so on, even the servers with the massive amounts of memory that they have won't be able to keep everything in place at the same time. So they'll need to stream in and out locations based on demand. So when a player goes to a location, or as he's heading towards a location rather, the server will detect that, go, okay, I need to stream in the entities that are there, all the planet and derelicts and whatever are around. So by the time the player reaches that location, it's all in memory on the server. The server has to coordinate that with the client itself and tell the client what it needs to stream in. So the entities are present on the client as well. And then when the player leaves that location, the server's free to unload that information, free the memory up for anything else.
We were talking just a few minutes before we went live, and this isn't a technology that we're inventing for Star Citizen. This juggling act of moving things in and out of memory in video games, this exists for many games.
Yes, yeah.
What's the difference with Star Citizen? Why is this such a big thing for Star Citizen then?
Well, map streaming is generally more common in single-player games. A lot, not all, but a lot of multiplayer games will confine the maps to smaller sizes, so that it can all fit in memory all at once. So once you've loaded in, all the memory is resident on your client. All the data is resident on your client. No streaming is required, and that cuts down the chance of any stalls or any frame rate hits. And makes for a smoother online experience. So the challenge is to do streaming during a multiplayer game, not have any stalls or performance hits, and it's also, as I say, it's about the scale that we're doing this on. Obviously, our maps are millions of times bigger than most maps of virtually any other game. So yeah, it's a question of scale and trying to do it while you're online as well.
Gotcha. So it's not that we're necessarily reinventing the wheel here. It's that we're adapting the wheel to a scale that's previously unheard of.
Yeah, we're probably one of the bigger games ever envisioned at this point. And we've done quite a lot of stuff over the last couple of years where we've had like snippets of gameplay like Star Marine or Thousand Commander, where it's been like a small contained bubble of the game, and we're now going, right, it's now that, but it's in this big massive universe that's making everything bigger. And by going, well, if we only need to stream in this one bit where the FPS is happening, the performance should be the same as Star Marine probably on the client. So
now, so that's why we want to do it. What's this look like when we get there? Now obviously 3.3, and you mentioned it earlier, and I'm glad you brought up the server side object container streaming is not a part of the work that we're doing right now.
Yeah.
We're working on the client side object container streaming. But once this is all done, let's jump ahead. You know how much I love jumping ahead to the far-flung future, but I'm going to do it this time. Once we jump ahead, once we've got bind culling, and once we've got server-side object container streaming, and then in the future, once we have server-side, what did I say that right? Once we have client-side object container streaming, and then later on down the road, once we have server-side object container streaming, what's that going to look like as far as performance? Does everybody suddenly just get 90 frames a second on everything? What's this picture look like?
Okay, it's not a silver bullet,
Mm-hmm.
as you kind of mentioned before. So we can't make any guarantees on how performance is going to improve. Partly because there's so many variations of CPUs and motherboards and RAM and everything else and GPUs that you can't predict how it's going to affect all the different combinations. So it's a best guess what we think is actually going to help. So what it's going to look like. So effectively the difference to what you have now is you start off in your bed at Port Olisar, and Yella is loaded on your client, and there are entities on your client in memory, hopefully idle and not doing anything if the in-range update culling is working correctly. The difference will be with OCS, you'll load into Port Olisar, and basically Port Olisar and a few entities for the what's it called, the star map will be loaded, and that's it. Any players and ships that are around your immediate vicinity will be loaded in. Anyone who quantum travels to your current location will dynamically be loaded in. Anyone who quantum travels away will be loaded out, and your client won't have any awareness of them anymore. So it cuts down the amount of memory that your client needs. It should cut down some of the performance overhead for maintaining all these entities of memory as well. I suppose as you move around the solar system, it will unload areas that are that it doesn't need anymore and load in the new ones. So you head off to Levski, it will stream Levski in for the first time, and that's the first time your client is aware of those entities in that location.
Okay. What criteria do we use for that? Is it just proximity? Is that the only criteria? It's we set a bubble or a streaming window around you, and anything within this area is visible to you, and anything that's outside is not loaded into memory?
Pretty much, yeah. It's not exactly a hard bubble. It's not a defined distance. It's actually the kind of the size the object will appear to you if you were to look at it. So an object that's twice as big, you will see it the same size as an object that's half as big, twice as far away. See what I mean?
Okay.
So a planet will stream out, well, no, that's a bad example. Yeah, Levski will stream out very far away, but a small spaceship like I don't know, a Gladius will stream out much closer.
Gotcha. So there's a like a tagging system involved, in like it's the system's going to know that if you're approaching Levski, to bring Levski in at this far away.
Yeah.
But if it's a Starfarer, to bring the Starfarer in at this far away, and if it's a Hornet, to bring the Hornet in at this far away.
Yes.
Like that. So it's an intelligent kind of switching.
Yes.
Between stuff like that, and is that and that's something at the end, when all is said and done, is that something handled by the servers or by the clients, or?
That's handled entirely by the servers.
Okay.
Yeah.
Interesting. All right. So the work on when we're doing, we've got notes because this is a pretty dense topic here. When the work started on this, it was originally envisioned as kind of 3 steps. Bind culling, which we've talked about quite a bit, then client-side OCS, which is what we're working on right now, and then later down the road, server-side OCS.
Yeah.
Let's talk real quick about bind culling, and what it is and what its role here is. If you can who wants to give me just the nickel version? What is bind culling? Anybody? 1, 2, 3.
Don't want to jump in when there's a program.
Go for it. Yeah, so
This is a test score.
This is I should have revised further. This is So this is the act of unbinding the entities on the client when they go out of range. So if you're too far away from stuff, it basically streams it out. Is the idea. There's quite a lot of implications for that for gameplay code, which I'm obviously slightly concerned with being a gameplay programmer. So it's the type of thing of, if I'm on one side of the universe and I've got to go and kill someone on the other side of the universe, I would normally, in the game just now you see a little objective marker, but that's not there because he doesn't exist on my client because he has been unbound. Or simply if you've got to have a comms call with someone who's too far away, he'll be unbound, or sort of similar things. And there's, from a more technical standpoint, we have the likes of all our entity pointers themselves. Well, as soon as something goes out of range, they'll all become invalid. You can't talk to that entity anymore because he doesn't exist for you. You can't, you can't get his status, you can't get the amount of health he's got because it no longer exists on your client. And you've got to be able to handle him obviously leaving and then him coming back again later on. So if you've got to fix stuff up, and if you've then got to rework your gameplay system to make it work with someone that's just came back.
So what are the answers to those things?
So for the likes of the markers, they were solved by having an independently streamable object. So that's basically saying we've got this little marker, which is a really small, lightweight thing. It's really far away from you, but the server's going to tell you that it has to exist in your client because you need to know some stuff about it. It's removed from the normal hierarchy, so it's not. If you've got a marker, for instance, on a person that's inside a ship, that's inside another ship, normally you would need to have all these zones all the way down to get him. In this case, it's just that marker, and it just gives you the zone position of the biggest zone that's still streamed in. So the planet or the root zone if he's just out in the middle of space somewhere.
I don't know, maybe I'm wrong on this. I'm picturing like when you're playing golf and you pick up your ball and you put a quarter down in its place. It's like so that you know where that thing's supposed to be. The ball isn't actually there anymore, but you know where it's going to be. And when it comes time for you to actually need to interact with it, it's going to know where.
Kinda. And it's also got the advantage of we can do things like because it's so far away, the position doesn't need to update constantly because it's so far away you can't tell if it's 10 centimeters out. So it can update every 30 frames or every 60 frames or whatever, which also obviously increases performance ever so slightly.
That's going to be a big one for server FPS.
Yeah, and it's more, we don't need to get the messages from the client, from the server as often, so it's not affected. And then once you get in range, once it gets fully bound, everything else has been unbound, so the network performance is then able to do the stuff. Yeah, and then obviously there's stuff I'm not as involved in, so like the radar scanning stuff has got to be able to work when the stuff it's scanning doesn't exist on your client. So a lot of the game code was changed from everything happens on the client to the client has to ask the server for some results, or it has to push requests to the server for things to happen.
We've seen that it's a big concern of the community. Is we're seeing it coming in the questions right now about how long range scanning is supposed to work if this thing isn't loaded if in your client universe it doesn't exist. How are you supposed to scan for it and discover it?
Well, I mean, even the likes of when Clive was mentioning how we decide if something streams out is based on how big it is on your screen. So if there's a Gladius that's 20 kilometers away, it's going to be 1 pixel on your screen, it can probably stream out, or it's going to be less than a pixel, it can stream out. There's some adjustments made to that for the likes of the radar. So the Gladius will be made to think it's bigger because it needs to stay around, because although you can't see it, your radar can see it, so there needs to be some kind of adjustment there, so you're still able to get the up to date and the high frequency updates to see where it is.
And how does serialized variables play into bind culling? It's serialized variables that in my terrible analogy, and forgive me if I keep using it, but the quarter that you put down is that what a serialized variable is?
I think also, one of the complexities of OCS is there's a whole interconnected bunch of technologies that all need to work. So there's serialized variables need to be there. There's the actual bind culling itself. There's the likes of the I've lost my train of thought now where I was going with this. Other technologies as well that all need to exist for it to work. The serialized variables are kind of like the thing that sort of almost, I don't want to say glues it all together because it's a bit of a cliched phrase, but for the likes of the marker, you'll have serialized variables that have all the data you need in it. The server will be able to tell you the data you need to have in those variables, how often you need to get it, and it will kind of do it almost seamlessly from a gameplay point of view. So we've just got the data we need to use.
And for again, just assuming that this is somebody's first show, what is serialized? What are serialized variables?
So serialized variables are the mechanism that we expose to the gameplay programmers to allow them to communicate over the network. So the game's built out of entities are built out of components. Components have these serialized variables, which are values that can change over time as the gameplay programmers assign new values to them. Those changed values will get replicated over the network to the equivalent entity on your clients. It will change the value of the serialized variable there as though it's being changed exactly by the server. So it's a remote control over the state of entities in the game.
Gotcha. I've had a number of conversations about this over the last year. I always, please correct me if I'm wrong, I always kind of saw them as like save games. It's here's something actively doing its thing, and then when it gets converted into a serialized variable, it's kind of like that's like the save state file for it.
It's almost exactly like that. We use serialized variables.
I'm understanding what's going on.
We use serialized variables not just for networking, but because serializing to a network, it doesn't necessarily need to be a network. You've got this serialization process that converts from the the native format that the program's running with into another format, and it could be the network, it could be a save game file, it could be the persistent database. So we use serialized variables for those three things.
Okay. Again, and forgive me, but these are the engineers and the programmers, so I am the layman in many things. It also, over the conversation, it's almost like I worked in professional baseball for years, and I imagine that when the catcher is giving signs to the pitcher, short form information that means long form stuff.
There's so kind of compression,
Yeah.
Not so much on the data itself. The way serialized variables save us. How to explain this? Okay, so one way of updating the state of entities in a game over the network is to periodically, every so often, just send the state over to all the clients. And that can be inefficient because you're sending the same values over and over again and nothing's changed. So serialized variables track when something has changed and go, okay, this one now needs to be sent.
Okay.
These ones that haven't changed don't need to be sent. So that saves us a lot of bandwidth.
It's kind of like when my mom keeps calling me and says, how are you doing? I'm like, I'm fine. Anything new? No, nothing new. It's like now the serialized variable is that she would only call me when something's actually happened.
Yeah.
Sorry, my mom doesn't watch the show, so I love you, Mom, in case you suddenly did. Dad watches the show, so. All right, so that's bind culling, that's serialized variables. We've talked kind of high level. Let's get into the work that we're doing right now, which is essentially full client streaming. That's the section of OCS that we've been focusing on right now. One of the big misconceptions that I wanted to address here is the notion that when 3 comes out, when Hurston comes out, that's all of OCS, that it's done, that it's there and we're done, and suddenly everything is great. You can see like he's just like, no, that's not. I could feel the heat radiating off him right now. We did bind culling. We got bind culling to a state where it's feature complete at least. Now we're working on full client streaming for Hurston and everything. When that's done and that's into your hands, and after you guys have beat on it through Evocati and PTU, and then even with our live testing environment, which is still a testing environment, once we've got that to a place where we're happy with it, I guess, or content with it, then we move on to server side client streaming. But I just want to, that's just to help paint a picture there. For full client streaming, the stuff that we're working on right now, what is full client streaming? Let's just start with a simple thing. We'll go from there.
It's kind of what we said already. I'm not sure what else we could say about it. So it's the server dictating what your client can see, what entities it's aware of, and as you move around, controlling, changing which entities those are present on your machine.
Okay, so bind culling is the tech of dropping things out and everything.
Yeah.
So
the
client side server.
Okay, so the difference between the two and how they fit together is object container streaming is something that we need for Squadron 42 as well. So a single player game. So it's very much the kind of traditional level streaming that we see in many games. So that controls. Let's break it down. So that controls the figuring out the distances of entities, what needs to be present and what doesn't. At the minute on the server, everything's present all the time. So we've just got this distance calculation based on entities that exist, and then it can do the streaming in and out. The other part of OCS is the asynchronous entity loading.
Mm-hmm.
So up until now, anytime we spawn an entity, it happens on the main thread, and the main thread will block for how long it takes to spawn that entity, and that includes the time it takes to load any files off the disk, so textures and physics geometry and anything else. Part of OCS is making that spawning process asynchronous, and by that we mean we tell it to start, and then when it finishes on a background thread, we get the results back, and the entity is finished, and we can put it into the game. Right, yeah. So those are the two parts of OCS that determine what a client needs to do, and being able to asynchronously spawn entities and get rid of them. Bind culling comes in by replicating those server-side decisions over to over the network, over to clients, so that the streaming happens for them as well. So it's server-side control of bind culling is server-side control of OCS on your clients.
All right.
Right. Yeah.
Okay. So, forgive me for asking a question. Tyler, our lead community manager, he takes the questions from the community and he feeds me up. And he's sitting here like, people in chat are saying, I don't have any questions. You're talking about all the things we want to, and I've been doing this for a while. The question that comes to my mind is, if we've got bind culling already, if we've got bind culling as a feature complete, what takes so long? What's the time sink here? What's this? It's if you've got the technology, you've got the code written, whatever. Where are the hours going?
Right now.
Yeah.
Okay. So yeah, we've got the async entity loading working. We've got the range-based decision making working. We've got bind culling working. It's now fitting those together, because what we currently have without asynchronous networked spawning is bind culling will say, okay, these, or what do we call it? The streaming manager will say, these entities are out of range for this client, you don't need them anymore. Bind culling will relay those messages, the client will drop them, and that's fine. But when you come into range of some entities and the client needs to spawn them, it will do a blocking spawn.
Puts them all on the main thread.
It puts
your
them all on the
your
main
game
thread.
lurches to a halt.
Yeah. So the changes that the part that we're left with now is changing the network messaging that handles spawning so that it can work with this asynchronous process, because the network messages as they currently stand assume this blocking synchronous spawn. As soon as I've said spawn, it will be spawned, and I can start sending messages to that entity.
Okay.
But because it's an asynchronous process, we've got to load the files from the disk. It can take, depending on the number of entities that we're trying to spawn. So,
Say a whole planet.
Say a whole planet. It's going to take a few seconds to do. So we need the client to start spawning, do all its work. When it's finished, go back to the server and say, I'm done now. Can you send me some updates? And then the server can start communicating information to those clients, to those new entities, put them in their final state because things have probably changed during the time it's taken. That's
From the time it started, from the time it finished,
Yeah.
something has changed.
Yeah, and then when all that process is finished, the client can finally go, right, I've got everything I need. I can put these entities into my local simulation and they can start interacting.
All right, Chris, you've gotten off light here, but you're working with the QA team that's testing this. You've been working with what's involved in testing object container streaming. What kind of things are you working with? What are you looking at?
So with it involving entities dropping in and out, it's a lot of traveling around, but it's also finding all the different entities, how we can spawn them, move them, change the state for one player without changing it for another, bringing the players back together, like the states of everything match up. And we're like looking for all the edge cases as well at the moment, because everything's fine apart from stalling when you start loading up. Like these flights are Levski. There's a stall as it brings Levski in. So I'm losing my train of thought. Sorry. It's all gone.
You mentioned when two players in there and the culling. If he and I are playing, say we're in a dogfight or whatever, we're a 3-person furball here, and I get so far away that the system goes, okay, it's going to cull it for me,
Mm-hmm.
but it's got to leave it for him because he's still in range.
Yep.
That's not as easy as I'm saying as I'm making it, is it?
And we'll be looking for things like, as you're dogfighting, you've got a mate in your cargo bay throwing a cargo crate out the back, and you're blowing up Gordon at the same time. As another player who, when he left, you were just dogfighting happily. He comes back, everything's different. Does his client show everything as it should be? Is the cargo crate there in space? Is your cargo bay open? Is Gordon alive or dead?
So it's all these different states.
A lot of different states. And one of the things that I've been looking at myself this week is we need not just 2 people doing it. 2 people seem to be quite easy to keep track of. What happens with the server when there is people or a group of people, not just out in space dogfighting, but you've got someone at Olisar, Grim, Hex, Levski, people out in space, people off in Hurston. So we've been using headless clients, which are just sort of low-weight clients that don't actually render the game, but we can give them basic commands. So we're filling the server.
The zombies.
Put in zombies. They do basic things. They'll get out of their bed at Olisar. They'll use console commands to zip around the solar system. So we're seeing what's happening with the server now. What's the load like when there's someone everywhere, or nearly everywhere, because the player limit is 50, and it's a big solar system, so you can't get everywhere with 50 people right now.
Yeah, it's I've no doubt, and I've heard in offhand conversation how anxious many people are to get this into testing, into wider testing. One of the advantages Star Citizen has in our development is that we run a live testing environment in the middle of our game development, and even from Evocati to the larger PTU to even our live alpha environment, even the live alpha environment is a testing environment. Guys like you and your team, QA here in Manchester and in Frankfurt and Austin and LA, you're knocking on pipes as much as you can.
Mm-hmm.
But I think it's safe to say that when this does go out, we're going to see a plethora, as El Wapo would say, of all new kind of issues, things that things that we've never seen, interactions with this system, the streaming, pulling it out of 4 people's thing, but not pulling it out of 2 people's things, and vice versa. It's like that will be a very interesting challenge for you guys to track down.
When that happens, we're not just going to be hitting the object container streaming new issues that have been introduced since the last time we did a live release. Other systems, other content has been updated as well. So
Yes.
We're going to be dealing with the bind culling object container stuff, working out what's going on there, and all the new fun issues that get introduced just from the general development elsewhere.
You hinted at a good point there. Object container streaming hits just about every single aspect of Star Citizen. I mean, everything's got to be converted. Or OSR's got to be converted. The asteroids around Yila have to be converted. I mean, everything that's in the game now has some kind of fundamental change to its underlying structure. So it's not just the new things like Hurston and its 4 moons that we're adding. It's also everything that's already in 3.2 gets a fundamental change. So new bugs that you're finding out and bugs that you're chasing can affect not just the new content, but every single aspect of Star Citizen today. Like maybe only Arena Commander is safe.
Yeah.
Are we doing anything with it? Yeah, I don't think OCS is touching Arena Commander yet. So is that daunting?
Yes, definitely. I personally haven't worked on that side of things. I think it's kind of more.
Yeah, I think the amount of teams even it touches, so likes of one of the changes we've been having to make for the async spawning stuff, everything has all the components have had to be made thread safe. All the components of the game have had to be made thread safe so they can be spawned off the main thread. For the actor, that means all the actor's components first need to be made thread safe. So you've got a bunch of components that need to be done by the audio team, a bunch that need to be done by AI, a bunch that need to be done by all these different people, and some components depend on other ones being done first. So I couldn't convert, for instance, the local player component until the particle stuff was converted.
Mm-hmm.
So we've got this big dependency graph that sometimes goes several levels deep before you can actually get there. And there's just an awful lot of stuff. There's 100 odd components on the actor now.
When you say components, you're not talking. Backers know components as the things in your ship. I mean,
Yeah, no, sorry.
You're talking about all the raw
Yeah, no,
components
this is,
in the most base vocabulary sense that make up the entire game.
Yeah, so it's our game runs off an entity component system. So the entity is like an actor. It has an actor component. It has a local player component. It's got an audio component. It's got all these various variety of different things. So there'll be ones for animation and ones for effects and all these plethora of different things, which will be shared between different entities as well. So there'll be other entities that also have animation components and stuff. But yeah, everything had to be made thread. Everything had to be able to be spawned thread safe. Sorry, not made thread.
So when I was asking before about where the time sync was, going through in every existing component of the game had to be just about every existing component.
I mean, we've already talked about how this has been an ongoing thing. Most of my last quarter, so quote Q2, was spent doing this for the actor. A big chunk of that was we had there's a scripting language called Lua that we use extensively in the game, and it basically had to go because it's not particularly thread safe, or there was no good way to make it safe for spawning things asynchronously. So it was a case of going through, for the actor there was an awful lot of Lua files, and there was an awful lot of stuff that just had been around since this engine was created. Everyone has evolved over the course of the engine, and yeah, it was just a lot of tidying up and cleaning up and moving things around, and again it was by multiple departments as well.
Now, as we're in, I said we talked a bit about how even once the client side streaming is done, the stuff that we're working on for Hurston and everything, there's still the whole server side that needs to come after that. But as we're approaching the finish line of our client side streaming here, what are you seeing in the game when things work? What's your gameplay experience like?
I overheard someone today use the phrase "truly amazing."
Really?
I don't want to oversell it, but yeah, I know the backers have complaints about performance, like quite legitimately. It's not at the state anyone wants it to be, but we're seeing really raw builds each day. Like typically our performance can be pretty terrible, but now everyone's reporting improvements. Some people are reporting drastic improvements. It's written nicer to test when you're hitting a really nice smooth frame rate.
Now, he makes a good point. I set Chris up there. I wanted to know what his experience was like. At the same time, part of OCS, and this is where I get to deflate the balloon a little bit, is improving the performance on everything that we have right now. But part of the reason we do that is so that we can add so much more to the game. So it's one of those things. It's like in my terrible analogies again. It's I'm carrying a 50-pound backpack, and OCS is me going to the gym and working out for 10 years, for 5 years or whatever. And now that 50-pound backpack feels like a 10-pound backpack, and I'm awesome. But the next step after that is to add 500 more pounds to my backpack. So it's that's one of those things where when we say it's not the silver bullet that fixes everything, there will still be a continuing network improvements. There will still be continuing optimization of every aspect of the game. It is a OCS is not the answer to everything. It's a foundational technology that allows us to continue building and expanding the Star Citizen universe to soon Hurston, and then to ArcCorp and Microtech and Crusader, and then the entire system, and then more systems beyond that. So it's one of the, it's interesting. I don't think we can predict, and I was asking around, I don't think we can predict, what kind of performance players will see with 3.3 yet, or when Hurston is added yet, because, well, we're still working on it, first of all. We're still putting it together. But, we make all these improvements to what we have now, and then we add more onto it. So it's a constant juggling. I think all of OCS is juggling. It's the server juggling things, it's the client juggling things, and then with development, it's OCS is like adding 50 more arms, but then we're going to throw 75 more balls at it and go juggle it.
What we're seeing now is like when you're in Port Olisar, you're not getting updates from Levski, Grimhex, anything like that. So performance is great. You go to Lorville, your frame rate is still dropping very low because you're still loading Lorville and everything that's in it.
Lorville's big.
It's getting bigger.
No spoiler there. Lorville is big. All right. So I think that's our deep background now. Now we're going to take questions. Tyler's been collecting some questions from the community. We also put up a thread earlier this week in Spectrum where folks who maybe couldn't join us live could submit questions. It also allowed people to vote on which question they wanted to see most. I'm going to start with the single most voted on question. Nearly 500 votes the last time I looked at it. It says, oh, actually, I already just answered this. Sorry. Can we expect performance improvements in the game because of OCS in its first iteration, or will it only work in making a larger verse viable, while maybe allowing more players per instance? So yeah, I just kind of answered that, didn't I? Is there anything else we want to add to that, or is that? Sorry, I got carried away. I went ahead and answered. They talk about the allowing more players per instance. Is that linked to OCS in any way?
No, that's not. So the performance benefits, the memory savings that you're going to get, if any, hedge bets, your mileage may vary, it is going to be purely client side. Server side, all those entities still have to exist on the server. They need to be updated when anyone's near to them. So the server load is going to be heavier than it has been in the past because we're increasing the scale of the solar system massively.
Right.
Massive amounts of new content. So I don't think it's likely we're going to increase the server count, the player counts.
So you just made a really good point there. These improvements when this system comes online is strictly client side.
Yes.
So the next step is the server side improvements, and until that happens, we're still adding a planet and 4 moons to these servers.
Yes.
So the load on our server side is going to increase.
Yes.
Pretty dramatically when this comes online. So yeah, it'll be interesting to see. I think we're all going to be looking at what the improvements are and how it all works.
Yeah.
When that time comes. All right. Let's see. Why are client and server side OCS split? From the live chat. Why aren't we just working on both at the same time?
So, yeah, okay. So, server side streaming requires some extra technologies that we haven't got yet. So, we're by working purely on client side streaming, we're getting some of the benefit onto our clients, and we're not having to do all the technology at once. So the kind of extra pieces that we need are on server side streaming. Once a server decides to unload some entities, what happens to them? They're going to have to be persisted out their current state, and then we're going to have to reload that state back in. So It's not clear if we need the full persistence to work, but it's going to have to be something pretty close to full persistence to get server-side streaming working.
Does OCS affect our view or render distance?
It shouldn't do. As I say, and as Gordon said as well, that the range at which entities get streamed out and streamed in should be pixel size or thereabouts, so you shouldn't notice anything. But because of the time it takes to load things in, there may be a little bit of pop-in, but it shouldn't affect the draw distance really. No.
Okay. What are the current improvements that OCS has already yielded? You talked a little bit about that already. Are there anything else that you guys can think of right now? Current improvements that you've already seen?
From a development point of view, it takes me less time to load the game, which is nice. So if I'm wanting to test very simple stuff and I only need OLSR, I just need to. The PU takes less time for me to load because it doesn't have to load all the stuff that's out of range.
Yeah, just so you can iterate between builds faster.
Yeah, so it's less of that.
It actually makes it possible to load the game as well, because the map's so much bigger now. Not everyone here has quite large memory machines, so some of them can't actually load the full map because it's that big. So they need bind culling on. Well, we've got two maps. We've got a cut down map and the full map. They either have to work on the cut down map, or if they want to load the full map, they have to turn bind culling on to be able to get it actually in working on their machine. It's that much bigger.
And the reduced memory is helping us as well with, I mentioned earlier about filling a server up, which is effectively using one tester's time across multiple machines. The less memory the game's using, the more game clients we can put on a single machine.
The headless zombies.
The headless, yeah.
How deep does the container tree extend? In other words, is there a limit to how many containers you can put in other containers? That's this deep?
Yeah, about that deep, yeah. So there's no limit to how many containers can be nested inside each other. A container, well, the solar system's built out of a root container, so we've got the Stanton system container, and then inside that there's a container for each of the planets, I believe, and the planets themselves contain object containers for the moons and the space stations and the planet itself. And then on those there'll be, like for GrimHex, there'll be the GrimHex object container, and then inside GrimHex there'll be object containers for the different shops. So I think we're probably getting on to about 7 levels deep there. But in theory there's no limit.
Okay. What's been the biggest challenge you've faced in the development of OCS?
I personally, I think you're going to get a different answer depending who you ask.
Yeah, well, that's the three.
I'm extremely tempted to say networking, but I'm not. I'm going to say that it's probably the stuff Gordon was talking about, the conversion of entity spawning over to be thread safe and asynchronous. It's been a massive effort, that, and also kind of the production side of things, because it's touched so many teams.
Yeah,
to manage all that, it's been.
He mentioned that. I was sitting with Luke Hale, who's the associate producer, who's handling a lot of this. Who wanted to be here, but he's actually in a production meeting right now. He was saying that some of the dependencies, like I need to work on this, but in order to work on this, this person needs to work on this, and for this person to work on this, some of the dependencies right now are 4 deep. Which is just to draw the thing. It's he's needing to work on something, but he can't work on something until he finishes his work on something, and he can't finish it until I'm done working my thing, and I can't finish until you finish working on the thing. Yeah. Why are you slowing us all up?
I apologize profusely.
Yeah, but dependencies are one of the major things, and that's what producers bring to this. And I know we wanted to have the producer on to have that final perspective on here. Just juggling all those dependencies and prioritizing. It's like your work is holding up 2 people's work, but his work is holding up 3 people's work. And figuring out that prioritization and where to put resources. That's been a major challenge. How about you at the end of this chain in QA? What's your biggest struggle?
I think the fact that it touches everything means we need to test everything. And it's not just testing everything with bind culling, because when you find an issue on our, say, the bind culling server, is it a bind culling issue? Sometimes you can't tell just from the symptoms of the issue alone. You go back to a regular server, you need to reproduce it there. So you're not just testing everything, you're testing everything twice. With it affecting things coming and going, these aren't tests you can usually do by yourself. You need 2 testers, preferably as many testers as you can get together, and we only have a finite amount, regardless of how many zombies I can necromance. So yeah, it's been a massive strain on just our resources of getting everybody we need to be where we need to be, covering as many things as we can.
One of the questions in the live chat just said, while testing OCS, have there been what's the funniest or most interesting bug you've encountered?
See, now you've said funny, all I can think of is crashes. There's been fun ones where you're trying to catch an AI who's decided to run away from you. I think this was earlier on, so he's in range flying away, and you had an issue where he would reach sort of like outside of your streaming window and he'd stop. So then you'd catch up, and eventually you'd get the updates from this AI and he'd fly a bit further because actually he's even further. So you're constantly having this little stop-start race against the guy you kind of trying to catch up, and you don't even know where he really is.
That doesn't sound very fun, dude. How will different hardware units like CPU or GPU or RAM or VRAM benefit from OCS? Is this something that can conceivably help all aspects of computer? You squeeze a little more CPU out, squeeze a little more memory out, or is it just only certain aspects of performance?
But I think mostly it's going to affect RAM. That's where you're going to get the biggest save. It should, I'm being a bit more cautious than Chris, it should have improved things on CPU. It probably won't have much effect on GPU or VRAM.
Yeah. I think from my experience of it in the last week or two, there will be CPU improvements probably, but we're also ramming a lot more stuff in. So although while there might be some gains, we've also got a significantly more larger amount of AI and such. So.
That's most of the questions that came in on both the Spectrum thread and the live chat have to do with people wanting to know how big the improvement is. And the difficult thing about that is that, like I said, we are adding every day. We are adding more things into it. Aspects of Orville are becoming art complete. The ships are finishing up. We're adding the Hammerhead, which is like the biggest ship we've added in the persistent universe at this point. So we're making all these improvements, but at the same time we're adding all of these new things. So it's hard. It's kind of like a shell game at the moment. Forgive me, I'm on an analogy trip. Keith is just, oh my God, you don't have to look at me like that. I know. But yeah, it's we will be finding out the degree of improvement together. Is basically, I think, the safest way to answer that question. Does OCS have any drawback?
Apart from the time it takes for us to test it, that's the only one on our end.
You mentioned earlier some of the challenges that involved, like the scanning things, like having to leave the markers when something is called and whatnot, so that people can still see it. And stuff.
Yeah, I think I don't want to generalize, but most gameplay programmers are quite happy to just assume everything exists all the time and sort of do things a little bit. I'd be very happy if I just did every single entity in the client at the same time, because it'd make my job a lot easier. Whereas now there's a lot of I've got to make sure every entity I'm accessing exists, and if it stops existing while I'm talking to it, what do I do? And lots of more technical challenges and more. It just requires you to think about things. Not that we don't think about things, but you've got to be very aware of the implications of a lot of this stuff might stream out, or I might, if I'm designing this feature, will it work when not everyone's here? Do I need to move it to exist on the server rather than the client? Do I need to tweak things to make them work?
I hear you. One of the questions that just came in the chat says, after this hits the community, You know, when OCS hits the community, how are they going to be able to identify bugs that are related to OCS and not related to something else? It's because, you know, many of our members of our community participate in the issue council, which is our fantastic tool that, you know, lets the community, you know, assist in the bug tracking and the bug discovery process. Like how do we know when something is OCS related, or it's not just one of the other thousands of types of bugs that?
I'd say any bug that you spot, report it to the issue council anyway, and let us sort it out. But probably the kind of things you're going to see are perhaps missing entities or stalls as you approach planets, or derelict or whatever. What else might you see? Some kind of popping as things appear.
Yeah, the likes of teleporting actors as one that's kind of floated around a little bit. So just seeing guys just jump around the place. Occasionally we call sort of issues like that.
One of the questions that came in was the difference between asynchronous background spawning and normal background spawning. I think we covered that a little bit. Is the only difference just whether it's on the main thread or whether it's on the secondary threads? Or
Yeah, the background part of that says that it's off the main thread. You can do asynchronous spawning on the main thread, but it's a bit of it's a different way of doing things. So for us, it's a very precise way of describing the process.
Gotcha. Let's see. We did cover quite a few of these. You mentioned that OCS is still necessary for Squadron 42.
Yes.
How does it play into Squadron 42? Just in the size of the full systems and everything when you're.
Yes, but basically again, it's down to the size of the maps.
Gotcha. All right. Yeah. Well, let's see. I'm looking for other questions that have come in. We've actually hit just about everything here. Is there anything else you wanted to? Like, if you could tell the community one thing about OCS, if you wanted to make sure that people understood one thing about it, what do you want to make sure people understand?
That it's been as you said earlier, like 3 years since we kind of started work on various parts of it, and although we've not everyone's been working on it flat out for those 3 years. Mm-hmm. It's taken a massive amount of time, a lot of changes, tons of people. It's not down to just us in this room or our teams in particular. It's a company-wide effort. It's been a long road, and it's hopefully worth it when we finally get there.
What you got?
Yeah, I think just sort of to reiterate that it's touched every single element of the game.
And it is still currently.
It is still currently touching every single element of the game. And like I said, it's a collection of features, but there's never been a feature that's really, there's not been as many emails that have come out to absolutely everyone going, is this going to break anything for you? It's needed everyone to be pitching in.
See a whole lot more BCC everyone.
Yeah.
On OCS threads than you do just about anything else.
And I think as well, as Clive said, it's not been a short road. I mean, before even object container streaming, there had to be object containers themselves, and that started as I was starting, so that's 3.5 years ago. So that was kind of the very beginning of it, and this has obviously been on the plan since then, and it's just taken 3.5 years of tech and improvements.
And it doesn't end with this next release in Hurston.
No, well, I mean, this is the kind of thing, it's going to be ongoing forever, probably. There's always going to be things to improve and more stuff that is added to it. Sort of the server streaming is obviously the next major step. And then there's stuff beyond that as well.
What about you, Chris?
Just to reiterate that it touches everything, and from the QA standpoint, there's
show me on the game where OCS touches everywhere.
It touches everything. There's going to be a lot of edge cases that, with our department, like as cool as everyone is, there's only so many of us. There's only so many evocati. There's only so many PTU testers as well. Even though there are a lot, things are gonna break. I think. Please submit to the issue council and always submit your crashes.
Yes, that'll be my point that I want to add. This is a massive undertaking that touches every aspect of the game. It's why I wanted to do this show. It's why when they gave me 1 week a year to come over here, I wanted to use it for this. You know, it's this. This is every department from UI to every system design, mining, FPS locomotion. I mean, every game system touches OCS in some way because of all the conversions to thread safe and stuff like that. When this does get into your hands for testing, whether you're on Evocati or whether you're in PTU or whether you're still helping us test once it reaches the live environment, your help on this is going to be appreciated. This is one of the biggest fundamental changes to Star Citizen that I can think of in the times that we're being here. And it's not just on the feature side, not just that we're adding a planet to this, which is a pretty massive change content-wise, but under the hood, we're making this massive change to how everything works under the hood. So it'll be an adventure. And I think for folks who have followed our development and continue to follow our development as it goes on, this will be one of those watershed moments when we look back and be like, oh yeah, I remember when they added OCS and everything was upside down and stuff like that. You know, it'll be an interesting thing to get through, and I'm excited. It's one of those building blocks and one of those growing moments for the game that we've been working towards for a long time. And I'm excited to finally approach the finish line, whenever that may be. So. Yeah, that's it. I got no other housekeeping. This was all I had to do today. So thank you so much, Clive and Chris and Gordon, for taking time at the end of your week to be here and to agree to this. I know it's not everybody's most fun thing to do. When I got into video games and I want to make video games, I did it so I could show up on live streams with Jared. So thank you so much. Clive, Gordon, and Chris. For Reverse the Verse Live, I'm Jared Huckabee. I've got nothing else to say. Tune in next week, but I'll be back in LA after my whirlwind three-week tour, and we'll find out what we're doing then. Take it easy, everybody. See you later.
Thanks for watching. For the latest and greatest in Star Citizen and Squadron 42, you can subscribe to our channel, or you can check out some of the other shows, and you can also head to our website at www.robertsspaceindustries.com. Thank you very much for watching.